Hello. We are going to go over 10-2 today, which is about measuring angles and arcs. You have measured angles before, but you have probably not measured arcs. There are a lot of similarities in these two. This is going to set the foundation for a few other sections, so I'd highly recommend that you take really good notes. So we're going to talk about central angles, major arcs, minor arcs, semicircles, and find their measures. We're also going to talk about arc lengths. I think I might have mentioned that on the last note slides, but I had that wrong. So, central angle, you should have taken notes on all of these words, drawn good pictures. I think the book does a very good job of illustrating what those items are. So a central angle is one that goes to the center and then it goes out to the circle. So 1 is a central angle, 2 is a central angle, and 3 is a central angle. If you add those all up, they equal 360. That is important to know. The angles of that slice of pie, and that slice of pie all add up to 360. So then it asks, find the value of x. Okay, so they give you some expressions, they give you some numbers. So what do you know that can help you? Well, a whole circle sums up to 360. This 75 can reflect down here as a vertical angle, another 75. And then you can even use these two and put those over there as vertical angles. So the whole circle equals 360. Got vertical angles. Okay. So then literally you add up your 275s, your 5x minus 5 and 7x plus 2, your 5x minus 5 and 7x plus 2 set it equal to 360. Simplify that down. Solve. X is 9. Minor arc, the shortest arc connecting two endpoints on a circle. So we use 2 letters to name this. The book does that sometimes and sometimes it doesn't. It's not very consistent, but we are going to use 2 letters to name a minor arc. A major arc, we're going to use 3 letters to name. So it's the longest arc connecting 2 endpoints on a circle. Notation of an arc, that's measure of arc AB. It's got a little arc symbol, which is equal to the measure of ACB, which is equal to x. So ACB is the central angle. If ACB is x degrees, therefore 85 degrees, the measure of arc AB is also 85 degrees. The measure of the minor arc is always less than 180 and equal to the central angle. The major arc here has 3 letters, okay? And its measure will always be greater than 180. So here, greater than 180. So once again, if this angle is still 85, which is what they're trying to point out down here, this is 85, you're going to take 360 minus 85, and then that gives you the measure of ADB. Semicircle is an arc with endpoints that lie on the diameter. Could have used this information in that last problem that we just did. That last example we did, we could have used this information instead. A semicircle equals 180. We had a semicircle option on that last slide to set it equal to 180 instead of 360. So diameter, you should know what that is. Talked about that in the last section. That creates a semicircle. Semicircles measure 180. This is going to be a huge key for us. I think in the last note sections, picking out the radius and the diameter was a huge key. In this section, picking out the semicircle, huge. So WC is a radius. Identify XZY as a major, minor, or semicircle. Then find its measure. So XZY is a semicircle because if this is a radius, that is a radius. If we have 2 radii together, we have a diameter. Now find WY and WXY. So find measure of arc WY and the measure of arc WXY. So what would those measures be? WY is 90, because if this is 90, that has to be 90. It's a minor arc. WXY is 270, major arc, because we've got a semicircle, 180, plus a chunk of 90, which is 270. And as we said on the last slide, XCY is 180. In the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So if you can say angle 1 is 60 and angle 2 is 60, you know arc FG and arc JH are congruent. This is another duh moment for me. All right, you have one of these in your homework. Find the measure of BC. Notice they give you a circle graphic with percentage information on it. So you're going to have to convert those percents to degrees. So if 39% of birds are found in Barrel Park, what would the measure of this arc be in degrees? So you do 39 is out of 100, 39%, 39 out of 100, that's what percents, how they work as numbers, is equal to how many degrees out of 360? How many degrees is this out of 360? Cross multiply and you get your answer. X is 140.4. So this chunk is 140.4 degrees. Does that look accurate? Looks pretty good to me. So set up a proportion. 39 out of 100, that's the percent, is equal to X out of 360 degrees. Find the measure of ACB. ACB. So that's a pretty big chunk. So we've got 10, 8, 19, and 39%. In this case, it will be easier to find the 24% and then subtract from 360, wouldn't you agree? Instead of adding all of these up and finding those, just find out what this chunk is, subtract it from 360. So two different ways you can be doing that. So I found out 24% is 24 out of 100 equals X degrees out of 360 degrees, cross multiply. X is 86.4, so that's for the squirrels, which that looks just about like a right angle, so that's good. 360 minus that gives me 273.6 degrees for the rest of that chunk, which also seems about accurate. Arc addition postulate. This is just like the angle addition postulate, the segment addition postulate. We've done these a bunch. So, the measure of arc XYZ is equal to the measure of arc XY and arc YZ. Imagine that. Find EB, arc EB. So they tell you this is 38, they tell you this is 90. Use the semicircle to your advantage or use the 90-degree angle to help. Okay? Semicircle. This is a diameter, which means that whole chunk adds up to 180. You can also see that there's a 90-degree here, so you can flip that over on the other side. So you can either take 180 minus 90, which is 90, since this side is 90, that side has to be 90. Remember, we want to find EAB. I fixed it on the last slide, but it's not fixed here. So that should also say EB. I told you the book's not consistent. All right, 180 minus 38 plus 90. So 38 plus 90 gives me this chunk. If I take 180 minus that chunk, I get this chunk, which is 52. And then I add 52 and 38 together and get 90. That's the long way. Be wise is what I would encourage you to do. All right, find the measure of BD. BD. Always look for the semicircles when you can. Do you see any? There's multiple in this picture. Don't just get fixated on one. So here's the one you should be looking at. If this is 90, this side is 90. We just talked about that. If this is 38, that would make this 52. I think we just found that. 52 and 52. Vertical angles there. So then you're going to take 90 plus 52, which is 142. And then that is going to get you the measure of BT. So I think I did 38 plus 90 plus x equals 180. That gave me 52. So I was kind of explaining how we get to that in the first place. I showed you another way. I mean, this is obviously another way. This is a semicircle right here. That whole thing equals to 180. All right, highly recommend you put this on your formula sheet so it's easy to find, easy to access. This is arc length. We'll be using this quite a bit yet. So, cursive L stands for arc length. Length of the arc, meaning like inches, centimeters, meters, over circumference, which we've worked with. The whole circle is equal to x degrees over 360. So whatever this chunk is, over the whole circle. So it's literally the length of this compared to the length of the entire circle is equal to the degree of this chunk over the degrees of the entire circle. I love that proportion. It makes so much sense to me. Okay? This equation is derived from that proportion. I see many high school students liking that equation. The equation doesn't necessarily make as much sense as that with the picture as the proportion does. So I choose the proportion because it makes sense. It's more logical. So we have to find the length of JL, round to the nearest hundred. JL. Tell us that chunk is 36. We want to find the length, not the arc measure. The length. You have to read. People mess that up all the time. So I know cursive L over circumference is equal to x degrees over 360. Remember the proportion and how it works. What pieces do they give you? They give me the 36. So I'm going to start right here. 36 over 360. They give me the radius, 6 centimeters. I'm going to plug that in. Only one variable is left, so that means we're good to go. See how this is the only thing left? Okay, so from up here, we're solving. We've got 12 pi down here times 36, which is what I have right here. 360 times L, which is what I have right here. Then I'm going to divide by 360 on both sides just to isolate L. So 12 pi times 36, type it in your calc, divide by 360. The length of the arc is 3.7699, which is 3.77 if you round to the nearest hundredth. So 3.77. Does that seem accurate? If this is 6, can that be 3.77? Seems reasonable. Okay, try this one. Find the arc JL to the nearest hundredth. Keep in mind, they give you a radius. They give you this chunk. This looks like a diameter. So this is a semicircle. If this is a semicircle, can we find the degrees here? Yes. So we're going to do length of that arc over 2 pi 14 is equal to 22 over 360. And I'm not going to lie here, that is inaccurate. That should be 180 minus 22 over 360. Then cross multiply and you get your answer. Looks like I went a little too quickly there. I'll have to change that on the notes slide. So once again, that should not be a 22. It should be 180 minus 22 over 360. So you should see that you get this. You could work it this way. Find the measure of this guy and then use that to find this, but I don't recommend that. All right, so I'll try to fix that in the notes slide real quick. Talk to you guys later.